Okay. Okay, we're going to use the cosine rule to solve a slightly more tricky problem. Well, it's tricky in a peculiar way. So we're given a triangle. I'm going to write that a bit more neatly. We're given a triangle with a straight line, and we're given some information about it. For example, we're given that that's 30 degrees. We're given that that distance there is 12 centimeters. Should be to the end there. This distance here is 5 centimeters, so that line there is 5, and that's x, and we've got to find x. Well, there it is, I guess, but we've got to find out how long x is. So what I'm going to do is use the cosine rule for this, and we're halfway there, because all I've got to do is just write it out in a slightly different format. That's A, that's B, that's C, and that's angle A in there. And we'll write the cosine rule out. A squared equals B squared plus C squared minus 2BC times cos A. And of course the way to think about it is that if A is equal to 90 degrees, it's not 90 degrees because 90 degrees would be a right angle, it's a lot smaller than that. If it was like that, then we'd have A squared, we'd have A squared equals B squared plus C squared because it's a good old right angle triangle. So we can just plug the values in for this because I've written it handily in the right orientation. So what's A? That's that one there, which is 5. A here is 5, you see, in our original triangle, equals B. You see, this triangle here isn't actually doing any good. All it's doing is allowing me to write it down in such a way that the cosine rule makes sense. So B squared is 12, or B is 12, so B squared is 12 squared, plus C was this one here, this side here, which is this x squared, minus 2 times, what's B is 12, times C is x, which we don't know, times cos A, and that A is given as 30 degrees. Now, mathematically, cos 30 degrees equals root 3 over 2. In a subsequent screencast, I might prove that for you, but for the moment, I'm not actually going to use that. I'm just going to use the calculator. If I say 30 cos, it comes out to be 0.866. You see, 0.866. Here, if I take the square root of 3 and then divide by 2, I get the same answer. Actually, if I subtract off cos 30, we should get to 0. Where's cos? It's this one. We should get 0 equals. And we don't. We get something times 10 to the minus 38, which is sufficiently small for sufficiently good enough for me. Okay, so we know what cos 30 is. So let's just write this. Here's our equation here. I'll just put a lasso around that and kill that, so I can put my next stuff here. So 5 squared, of course, is 5 5s, which is, of course, 25, equals 144, because it's just 12 squared, plus x squared, minus 24 times x times cos 30, which is 0.866. So 0 equals 144 minus 25, because I've taken this 25 over the other side, plus x squared, minus, let's work out this coefficient here, it's 24 times 0.866. So I may as well do it exactly. 30 cos, that's, look, it's 0.866 something, times, what was it? Times 24, this 24 here, 24 equals 20 point, I'm just going to call that 20.8. It's difficult enough without retaining all these numbers anyway. It's 20.8x, because look, it's times x in the middle there, you see. Okay, so what's 144 take away 25? Well, that's, oh dear, 144 take 25, 14, 3, 1, 9, 119. So it's 119 because that's 144 minus 25, plus x squared minus 20.8x. And I'm going to rewrite that in a slightly different way. I'm going to say x squared minus 20.8x plus 119 equals 0. All I've done is reorder the terms there. So we've got a nice little equation here. So the cosine rule here has given us an equation for x, which is this side here, in terms of that and the cosine of that 12, that 5, and the cosine of this angle here, which is cos 30, which came out to be 0.866. Now, I'm sure you'll remember that the solution for a quadratic equation is this. It's minus b plus or minus the square root of b squared minus 4ac over 2a. And in this case, what have we got? We've got a equals 1 because the coefficient of x squared is equal to 1. We've got b equals minus 20.8 because it's minus 20.8x. And c equals plus 119. There, 119. 119. So all we do is plug and chug. So minus 20.8 is 20.8. Plus or minus, I'm just going to go through the formula. The square root of b squared, 20.8 squared. 20.8. Have we got squared? Oh, it's there. Look, 20.8 squared. But before I do that, we know that 20 squared is 400. So 20.8 squared is going to be a little bit more than 400. Probably going to be about 430, something like that. Oh, 432. Okay. It's always nice to estimate these things. 432 with some decimal places that I can't be bothered. Minus 4ac. Well, there's 119 times a is 1, so 4 times 119. 9 fours are 36, 7, 176. And that's square rooted, so it's to the power of a half, over 2. Because it's really over 2a, but of course a is equal to 1. Okay, well, what's that? That is 10.4, because that's half of 20.8, plus or minus a half square root of what's 423 take away 176. I'm just performing this subtraction here. Well, we borrow 13, we've got 9, which is 11. That goes down to 3. 13 take away 6 is 7. 247. Sweet. Well, let's work out what this is. It's 10.4 plus or minus a half of the square root of 247, which I can't quite work out in my head. 247 square root is 15 point something, and we need a half of that, so I'll divide by 2, and that comes out to be 7.9, let's say. Oops, 7.9. Okay, so we've got two solutions. We've got 10.4 plus 7.9, 18.3, and we've got 10.4 minus 7.9, which is, that goes to 14, and that goes to 9, it's 2.5. So we've got two solutions, 18.3 and 2.5. What's going on? How come we've got an equation, perfectly sensible equation, and we've got two solutions? Let's go back to where we started, which was this system here. If you actually made a triangle out of steel with 12 centimeters and you made this angle here 30 degrees, and I said this angle here had to be 5, well, look, there's two places it might join. Both of those sides are both 5 long, and they both meet this angle here, which is at this side here, which has got an angle of 30 with the base there. So when I said find x, it's not well specified because there are two distinct solutions. And after you go through all this process here, we come up with a quadratic equation that's got two solutions. If you draw that quadratic term, it looks something like that. It's got two solutions, and those two solutions are what you find. So the cosine rule is again giving us useful information about how triangles work, and I'm going to stop right there.